Hello, and welcome to the latest episode of Michigan Aerospace's podcast, a series of conversations with researchers in aeronautics and astronautics at the University of Michigan. Joining us today are the faculty experts in the new Michigan Initiative for Sustainable Aviation, or MISA. We're here to learn more about sustainability issues facing the aviation industry and Michigan Aerospace's efforts to mitigate the environmental impacts through collaborative research. Welcome, everyone. Can we start with some brief introductions?
My name is King Martins. I'm a professor of aerospace engineering here at the University of Michigan. And I've liked airplanes since I was a kid, and I've been optimizing airplanes all my career.
Hello, my name is Gökçin Çınar. I am an assistant professor of aerospace engineering here at the University of Michigan as well. And I work on designing, integrating, and optimizing complex systems with a particular emphasis on electrified aircraft propulsion and sustainable aviation. Happy to be here.
Hi, I'm Max Lee. I'm an assistant professor of aerospace engineering here at the University of Michigan. My research and teaching interests are in air traffic management, air transportation systems analysis, airline and airport operations, as well as emerging aerial mobility modes. Thanks for having me.
Hi, I'm Carlos Cesnik, the Kelly Johnson Professor of Aerospace Engineering here at the University of Michigan. My research focuses on multiphysics modeling, analysis, and simulation of dynamic aeronautical systems, in particular problems related to the advanced aircraft configurations that can reduce or eliminate emissions for sustainable aviation, but bring challenges related to controllability, safety, and passenger comfort.
Since we're here to talk about sustainable aviation issues, can we start with the foundational question? I'd like to know why aviation is important. Professor Martins, can you take this one?
Yeah, so I'd like to say that aviation makes the world go around, and it's really the only way to move something or somebody across the world in a day or less. So it connects people, cultures, communities, also helps the economy directly and indirectly, promotes international trade. It's really essential for the whole tourism industry. It also helps technology development because many of the technologies developed in aviation and aerospace more broadly have been transferred to other modes of transportation and also engineering systems. Now, air transportation is also critical for humanitarian efforts like disaster relief, medical evacuations, search and rescue. And one less tangible benefit that aviation makes it easier for people to explore new places and experience different cultures. And that ends up contributing to a great appreciation of the world and understanding of humanity. So in the end, aviation makes the world a better place.
So what are some of the biggest environmental challenges facing aviation today?
There are several environmental challenges, I would say, that we could address. Let me focus first on emissions. While aviation is not currently the main source of emissions, which accounts for about 2 to 3% of the total CO2 emissions and about 12.5% of the emissions related to the transportation sector, we have been doing them at high altitude. What can make the absorptions of those emissions, in particular the CO2, to take longer than other emissions, particularly the ones coming from the ground. Of course, CO2 emissions are not the only emissions we are concerned with, and they all need to be addressed as well. Aviation, however, is very visible, and with the increased climate concerns, our passengers, mainly in Europe, are really looking for alternative means of transportation, something more sustainable. In part, most people don't really know how efficient aviation is today, even though, of course, we can do better.
To figure out how efficient aviation is today, we can compare it flying to driving a car. And if you compare it on a fuel consumption per passenger per mile, flying is about the same as two people driving on a hybrid electric car. And that might be surprising to many people. However, the airplane flies 8 times faster, which is a huge advantage. Now, of course, today you have full electric cars. And if you compare the electric car on an energy per passenger mile, now the electric car is almost 3 times better than a hybrid. So aviation needs to catch up with this. Now, since the first jet airliners in the early 1960s, we have improved efficiency of airplanes by over 80%. As Carlos mentioned, aviation is about 2% of global carbon dioxide emissions. But that percentage is bound to increase drastically because other sources of energy are much easier to decarbonize, like electric cars, for example. So why are airplanes so much more challenging? That's because they need to produce lift, and producing lift requires additional thrust and therefore more fuel. So what you end up with is a trade where for each additional pound of payload or passenger, the airplane total weight must increase by 4 times that, so 4 pounds.
And let's not forget that there are other potentially harmful emissions associated with aviation as well. So, for instance, water vapor is a greenhouse gas emission, and it contributes to the forming of condensation trails, which can have a significant impact on global warming.
And to add on to everything that Carlos, Kim, and Gökçin have talked about in terms of the emissions and other impacts, there's also things that are not related to emissions at all, which is certainly part of environmental considerations. For example, as air traffic is expected to continue to grow, you'll have more planes coming in and out of airports, generating more noise. The other factor to think about is who is being actively harmed by these noise impacts. It's going to be the people who are living directly around and underneath the arrival and departure routes coming into and out of airports. A lot of the times, those folks tend to be socioeconomically disadvantaged, and also people of color who are maybe not able to, protest against certain expansions or changes. So, I just want to wrap up with saying that we have to think about who is actively harmed by these environmental impacts as well.
So given all of this, what are some solutions being considered for the environmental problems in aviation today?
The aviation industry is considering a range of solutions to address the environmental challenges that we face today. Some of these solutions include the development of more fuel-efficient engines and airframes, because efficiency at the end of the day really helps with the CO2 and other emissions, reduction of emissions. Improvements in air traffic management and operational practices is also another solution that we consider. We are also testing the use of sustainable aviation fuels on existing aircraft, and these fuels can substantially reduce the net CO2 emissions when we look at the life cycle. And in addition to these materials, technology is another critical area of research, with efforts focused on developing advanced materials that are lighter, stronger, more durable to improve, again, the efficiency and the performance of the aircraft. We have a growing interest in eco-materials, which are materials made from sustainable or renewable resources that could further reduce the environmental impact of aviation. In addition to these, there's a growing interest in disruptive technologies, such as electric or hybrid electric aircraft. So these aircraft, for instance, are fully or partially powered by an electrical source, such as rechargeable batteries, generators, hydrogen fuel cells, or any sort of combination of these. And these aircraft could significantly reduce emissions from air travel, but maybe not now, but in the future. Hydrogen combustion, in other words, using hydrogen as a fuel on aircraft, is another promising technology that is being considered for the far term. And MISA is actively exploring many of these solutions through research and education.
So it sounds like MISA is really bringing together a collective of experts across the world. And you are representing academic research, but we all know that solutions really take collaborative efforts across different types of organizations. Can you talk about the infusion of industry and government and organizations in the activities of MISA?
Yes, Sheila, the aviation industry has set some ambitious goals towards sustainability. For instance, back in 2016, the International Civil Aviation Organization, or ICAO, has set some long-term aspirational goals for the overall in the aviation industry to reduce the net CO2 emissions by 50% by year 2050 relative to 2005 levels. While ICAO provides guidance and sets goals for the industry, it is ultimately up to individual countries and airlines and manufacturers to develop their own plans for achieving net zero emissions. So these goals that ICAO set are part of a broader industry-wide commitment. Several airlines, aircraft manufacturers, airports, as you might have seen in the news, have set their own net zero goals or emissions reductions targets in alignment with the ICAO's long-term aspirational goals.
So it takes a lot of different organizations to come together, working collectively on these issues. But within the confines of the aerospace engineering applications, there's a broad number of disciplines that need to work together. Can you speak to the collaboration happening in MISA along those lines?
So yes, I can take maybe one aspect of that focus on the aircraft. It's this marvelous machine that balances several different requirements to make it safe, effective, and efficient. It requires several disciplines to work together: aerodynamics, materials and structures, propulsion controls, systems engineering, and so on. The balance can be achieved by a compromised optimization that must take into account new technologies that can change the shape of what we know as the aircraft of today. By relying on mathematical and computational tools, we can investigate different concepts to enable the sustainable aviation environment we are after. And this is what the core of our team has been working on.
Yes, and to achieve the net zero goals that we've talked about earlier, it is essential that we bring interdisciplinary approaches from multiple perspectives together. The challenges that we are facing today are complex and they require a diverse range of expertise. The design and certification of these revolutionary aircraft that we talked about require expertise in obviously aerospace engineering and regulatory compliance, but that's not all. For instance, battery technology is crucial to the development of electrified aircraft propulsion, and aerospace engineering is obviously playing a crucial role in setting the targets or assessing this technology. But advancements in the battery technology require expertise in material science, chemistry, electrical engineering. And in addition to that, when the technology is ready, we need to be able to adopt it seamlessly. So we need, for instance, charging stations installed at airports, and we need the infrastructure to be ready. And that requires cooperation and coordination with the energy industry and the infrastructure development. So that's why we need interdisciplinary approach and interdisciplinary collaboration across multiple fields, including engineering, but also science, policy, industry. And that's why we created MISA. So we hope that MISA is going to be a multidisciplinary research and education center that will bring together these diverse perspectives and knowledge to develop these sustainable solutions for the entire aviation industry.
I always like to think that we also practice what we preach here in terms of interdisciplinary approaches. As one example, Gökçin and I are actually working on a collaboration on how airlines could infuse electric and hybrid electric aircraft technology into their schedules in a seamless and efficient manner. So that's a combination of both flight operations and scheduling perspective, which is more on the operations research and optimization end, plus the electric aircraft technology end, which of course involves the batteries and also aircraft sizing and modeling and simulation. So this fusion is really where I think we'll get the most bang for our buck in terms of these improvements to sustainable aviation.
What precipitated all of you to collaborate and create the Michigan Initiative for Sustainable Aviation?
Yeah, that's a great question. And as I said, Michigan, we have been working on this problem, but we have just recently concluded a comprehensive strategic planning exercise so that our Michigan aerospace experts worked alongside selected private sector leaders into a really deep dive on the state of our aerospace enterprise and the great challenges facing us as we move forward. So there are different great challenges that were mega trends that were identified. Sustainable aviation has come loud and clear. While we have chosen to focus on commercial aviation, it's a significant challenge for the Air Force mobility and the space sector as well. We are committed to address this challenge head on, and in our effort are part of a large endeavor from the College of Engineering and the University of Michigan at large to address climate changes, sustainability, advanced mobility, electrification, and hydrogen as clean source of energy.
Yes, and on top of that, the University of Michigan has a long-standing commitment to sustainability. It has established several initiatives to advance sustainability research. For instance, the Graham Sustainability Institute and Energy Institute are two such initiatives that have already laid a strong foundation for sustainability activities at the university. And MISA fits in with this landscape by bringing together experts from various disciplines specifically to collaborate on challenges associated with sustainable aviation. So as a multidisciplinary center, MISA can work in conjunction with other sustainability initiatives here at the University of Michigan to bring a holistic approach to addressing these challenges in our aviation industry.
Can you talk about the different research perspectives you bring to addressing sustainable aviation issues?
Yeah, so my research is on computational methods for multidisciplinary design optimization, which is ideal for airplane design because airplanes, as Carlos mentioned earlier, require considering many different disciplines: aerodynamics, structures, propulsion, control. And multidisciplinary optimization lets us design airplanes that make the best compromise between weight and drag for minimum energy consumption. So my group has been working with NASA, Airbus, Embraer to improve wing design methods to explore what the wings of the future might look like. The conclusion is that they will be a lot longer than current wings.
Yes, so from my end, those long wings is what have been driving my research. We get this high aerodynamic efficiency coming out of longer wings, but with that comes a lot of dynamical challenges. And those in particular are the ones I'm concerned in my research, and my group has been working with both government and industry to address those types of problems. They impact the safety of the operation, impacts the ride quality the passengers will feel. And for that, there are advanced techniques that we use from controls, from ways of automating the flight that can impact. And we want to bring these kind of concepts early on into the aircraft design so we can take advantage of that and make these airplanes profitable and passenger friendly.
And I work on problems regarding how to bring these various technologies together on a feasible aircraft. So how do we make sure that these technologies, these components work together in a way that we get the most benefit out of the entire system, out of the entire aircraft, may it be during the design or operation of these concepts. So these systems can be any type of conventional or novel configurations, but the end goal is to get the most environmental benefit and efficiency out of them.
And then finally, I'd like to say, I think my colleagues here will be building the future aircraft that is environmentally friendly and has less emissions. My research really focuses on how do we integrate them into the operational airport and airline environment. So with respect to my interest, which is in air traffic management and air traffic control, the way I like to think about it is if you froze technological advancements on the aircraft and just had to operate them more efficiently, what can we do? So can we have them fly better paths? Can we plan better schedules that allow us to put more efficient aircraft on the most commonly flown paths? How do we integrate that into the schedule? But I always like to say that I am a augmenter from the perspective of sustainable aviation. Just by improving air traffic management, you might only get somewhere around 6 to 10% improvements, Where the real advantage comes in is if we have one of these futuristic aircraft, how do we actually allow airlines to effectively use them in their operations and fly the schedules they currently fly and not risk any loss of demand nor capacity?
Thank you all so much for contributing today and sharing information about not only the challenges in the aviation industry, but your approaches and your efforts to collaborate and seek solutions. I want to offer the opportunity for any closing thoughts any of you might have.
Yeah, so when I first started working on sustainable aviation over 10 years ago, NASA had the goal of reducing CO2 emissions by 60% by 2025. And NASA funded my research to optimize new efficient wings as one of the efforts. And that did reduce the fuel burn, but we are not hitting that target. However, what's very exciting to see is that the industry is doubling down now and is targeting zero emissions. And given the new developments, I see this as a feasible target with a great increase in green electricity, new electric propulsion technology, and carbon-free fuels like hydrogen.
So I think the other thing to emphasize is you really don't have to be a faculty member or even a student to get involved with the push for a more sustainable aviation and aerial mobility future. In fact, as a member of the general public, I would encourage you to try your best to stay up to date with new innovations or proposed regulations and policies, and then go out there and vote for the changes that you want to see or advocate for the changes that you want to see. And also, if you are interested in contributing, to research, to the study of sustainable aviation and how we can push this industry into a more sustainable future, get involved. We are always looking for new faces who might bring new perspectives that those of us who's been looking at this problem for a number of years may be needing. So just in general, get involved.
Yes, and it is true that there's a long way ahead, but the need for sustainable aviation has never been more pressing. So I believe that our efforts at MISA are multidisciplinary and pioneering in nature. We are thrilled to have already started garnering global attention in such a short amount of time, and we call on our industry partners, interested organizations, and stakeholders to join us in this important journey towards a more sustainable future. Let's work together to create innovative solutions that will benefit all of us. So you can join our mailing list and get in touch with us for partnerships in research and or education. And together we can create a greener future for aviation.
And just to finalize here, as my colleagues, King, Max, and Gökçin have already said, these are really important problems. Those grand challenges, although daunting at first, it's where knowledge, science, and technology can really support and help us solve this and evolve as a society to a much more cleaner, a more sustainable, equitable form of energy consumption. So keep looking for what is coming out from MISA. We are very excited in working on that. We are very excited in working with all our students, all our colleagues, and the people in general. So join us in this effort. Let's solve the problem and let's leave a better world for our kids.
Thank you, King, Carlos, Gökçin, and Max. We hope you've enjoyed this episode of the Michigan Aerospace Podcast. Find more episodes on our YouTube channel or our website at aero.engine.umich.edu. Thanks for listening.